Hello, everybody. Welcome to day one of anatomy. I am super excited to have you in class this summer, and I'm going to go over briefly the course syllabus as well as lecture number one today. So I'm going to first start by sharing my screen, I think. Here we go. Okay. Again, all this information will be posted for you on eLearn as well. Just want to highlight a few things on this document. My cell phone number is here and also my email. So feel free to reach out to me either way. Either way is completely fine. I have no problems. If you want to text me or call me or whatever's easiest for you, I'm happy to respond in either way that way. In terms of meeting times for this course, traditionally, it's set up so that it's taught every day, Monday through Friday from 8:30 to 12:30. Certainly, I want to give you some flexibility with that as well, because some of you might be working or doing other things as well over the summer. So my plan is to have Zoom sessions on Monday, Wednesday, Friday at 8:30. We'll use those times to go over our labs, which will be fairly interactive. And then Tuesdays and Thursdays, you'll be on your own. I'll have an audio recording, such as the one you're watching right now. And then you'll also have probably a quiz or a test every day. I have those set up to be at 8:30 a.m. every day. And again, I'll show you the course calendar that kind of outlines what all of those are. I can be more accommodating than that if people need me to be. And again, I'll check in tomorrow when we talk for the first time via Zoom to kind of find out if that's feasible, or if you want to have a little bit more flexibility with that, we can do that as well. This is not the first time I've taught this class online. This is my 7th year at Loras College. I'm the kinesiology program coordinator. I developed this course when I came to Loras 7 years ago. So I've taught it many, many times. Before coming to Loras, I was a faculty member at Buffalo State University, which is in New York. And when I worked there, I did teach this class regularly as part of our online summer curriculum. So I do have quite a bit of experience with online learning. So I hope you enjoy it. And again, we'll do the best we can to make it fun and interactive, especially for that lab piece. So again, this gives you a little bit of our course information. Required textbook, you can see here, Human Anatomy by Marab is the textbook for the lecture. I don't think any of you have had me in class before, but the information that you need to be successful on our exams will come from the lectures, okay? So I'm never gonna ask you what's on page 632 of the textbook or anything else like that. The textbook is a great reference for you, and I also use the textbook to get my information, so that's where the information from the PowerPoints generally come from. However, I'm not gonna ask you things from the textbook that are not included in the lecture or in the labs. So it's really up to you whether or not you'd like to purchase this Human Anatomy 7th edition. Okay, anatomy coloring book. So I would like you to purchase that. Again, it's not very expensive, and I think it'll be a great study tool for you. We'll also use some of that stuff, I think, for some of our lab assignments as well. So I would like you to purchase that. And again, I'll give you all the details about that tomorrow when I meet with you in that Zoom session. And then also this Muscle Premium Visible Body app. For this summer, it is free to use. So we'll get you set up with that again tomorrow when we meet for lab. So we'll get those things kind of taken care of. So in terms of textbook expenses, it's pretty cheap. Again, you can use this Marab book. You can get an older edition if you want to. If that's a little bit cheaper for you, that should be no problem. The material should be pretty similar. I'll go over how to get this coloring book tomorrow. And then, like I said, this Muscle Premium, I believe, is free for students for the summer. So we got that going for us. Course description, course objectives, you can read over those kind of on your own, learning objectives. Again, as it relates to the online delivery of this course, I plan to have, like I said, those labs on Monday, Wednesday, Fridays at 8:30 a.m. That being said, they're not mandatory. I would highly, highly, highly encourage you to be at those if at all possible. If not, that's okay. I will record all of them and have them available for you to watch at a later time. But I really do think that being, an interactive member of the class will be super helpful for you in regards to facilitating your learning, okay? Like I said, on Tuesdays and Thursdays, you're kind of on your own and you can do things at your own pace, whatever you want, whenever you want to do those audio lectures, you can watch those on your own. Again, as I mentioned, you can feel free to email me. You can also call or text me. Please do one of those things. If you want a very prompt response, I would try my cell phone first, but then, email is also acceptable as well, and I'll get back to you as soon as I can with those. I'll be checking those very regularly in that allotted class time, so 8:30 to 11:30 each day, Monday through Friday. Okay. Definitely, I still will have, I'll still have access to my phone, later in the day, in the afternoon or whatever. So if you do have a question, you're like, oh, I'm not really sure about this, just text me if it's later in the day, and that's completely fine. I probably won't be checking my email quite as frequently, at night and those types of things. I do have a 2-year-old son, so I spend time with him in the evenings and in the late afternoons and things. So I won't be checking my email as frequently. So if you want a very prompt response, it's something you just had a quick question about, then please text or call. Okay. Again, online support for technical help. You can see the information there for help desk and their information listed. Assessment of the course, there's 5 quizzes throughout the course. Again, quizzes, you'll be able to use your notes, absolutely. Make sure you take very good notes though, and make sure you study those beforehand. All those quizzes are timed, so they're not, if there's 15 questions, you only have 15 minutes to complete the quiz. So once you log in, you need to make sure you, know what you're doing and are prepared to take those quizzes. Okay. Lecture exam, 2 different lecture exams. Again, the lecture material and lab material in this class are fairly separate. So the lecture material is going to be focused on general anatomy, and then our labs will be focused on musculoskeletal anatomy specifically. So we'll be learning all the bones and the muscles of the body, as well as what their movements are, and that sort of thing. So again, they don't necessarily go together perfectly. So think of them as kind of 2 separate components. So our lecture exams will be exclusively lecture material, and then your lab exams will be exclusively lab material. So those muscles, the joints, the joint actions, and that type of thing. Okay. You'll also have homework assignments for each of those lab sessions. The homework, I will tell you, is not hard. Okay, you do have to spend some time and do it, but conceptually it's not challenging. So really what we want to do is use that as a study tool for you. Grading is listed here. So again, that's kind of how the points are awarded. I won't stray from that. Everything is set up for this class ahead of time. So I have everything ready to go for you in regards to those quizzes, those exams, those lab assignments. So those points totals will stay the same. So 800 points available in the class. Here's our final grading scale. Again, it's just a standard grading scale. I put it in the points version because students like that, because then they can see, oh, I need to get, 80 more points to get X grade in the class or whatever, however, that works for you. But again, 90s are an A, 80s for B, 70s for C, etc. Again, as I mentioned, I'm not necessarily requiring attendance for those Zoom sessions because I understand technology can be an issue. Other things might come up. However, I would highly, 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 highly encourage you to attend each of those. Again, I think it'll be really good for all of us to be on a consistent schedule. So doing those on Monday, Wednesday, Friday at 8:30, I think that will be really good for us to get a little bit more stability in our lives potentially. So I would, like I said, I wish I could require those, but they say I can't. So just make sure you do everything you can to attend each of those. Late work, again, like I said, you're going to have all the course information that you need pretty much in advance. So you can work ahead on things if you want to, but don't get behind, right? So again, you can hand things in late, but you take off 5 points for each day that something is late. And a lot of those assignments are only 10 points. So just make sure you get things done on time. Dishonesty policy as well as our accommodations are listed here as well. Okay. So now I need to go to share a new screen. I'm going to share with you the course calendar. Next. Okay, again, all of this, like I said, is available for you. We'll have Zooms on Monday, Wednesday, Friday. You can check your email. I'll be sending you the Zoom links for each of those meetings ahead of time. And then, like I said, on Tuesdays and Thursdays, you'll have either a quiz or exam at 8:30 a.m. Again, we can talk about that tomorrow when we meet via Zoom, and then you can tell me if that doesn't work for you and we need to change that. I can be flexible with that. Okay, so again, everything's pretty much laid out here. We'll follow this calendar to a T unless, I don't know why we wouldn't. I've never strayed from a summer schedule before. So, that's what's going on, but we'll stick with it. I will give you a warning now. I am pregnant with twins. I don't think that should affect you. I am 29 weeks pregnant now, so I am extremely hopeful that I will make it through both sessions of summer school with no issues. However, if something comes up, it could be related to that, and certainly I will keep you in the loop if something does happen. But again, not planning for that to happen. So again, this is available for you on eLearn. I would encourage you to print it out and cross things off as you get them done. Okay. Alrighty. Again, any questions that you might have about the syllabus, please don't feel, timid to ask. You can, like I said, reach out to me in any form via email or text or call is great as well. So now I'm ready to start talking to you about anatomy. This is one of my favorite classes to teach. I love teaching it every summer. Again, it's just kind of fun for me to cover this information in the summer. I don't teach the lecture during the school year. I do teach one of our labs during both the fall and the spring, but the lecture is something that I only get to do in the summer. So again, I enjoy teaching this. So again, what are we talking about today? So we're going to do kind of an orientation to the human body and take a look at anatomy in general and why it might be important. So again, topics that we're going to cover today. Hang on, let me get my little pointer out. Okay, introductions, we'll go over those tomorrow. I can't wait to meet each of you and hear what your story is and what your, your career path is that you're interested in. So I'm looking forward to meeting each of you tomorrow. I already introduced myself. I'm Dr. Beekler. I am in kinesiology. I come from an exercise physiology background, so my PhD is in exercise physiology. I specialize in sports performance. So a lot of my research revolves around sports nutrition, particularly for endurance athletes, also recovery modalities for athletes, but in particular endurance athletes are kind of my jam. So I've done a variety of different things with recovery mechanisms. So if you've seen like the Normatec compression boots, I've done some research on those. Started to do a research project this last spring on Theragun. So if you've seen those, it's like one of those massage guns. We were looking at their effectiveness in comparison to ice bath. That's another project that we'll continue working on this fall. And then I've done some things with features compression socks as well. So quite a bit of material related to recovery. Again, I teach exercise physiology, strength and conditioning, sports psychology, regular or introductory nutrition class, a little bit of this, a little bit of that, but I do very much enjoy teaching anatomy and phys in the summer. So that's a little bit about me. Course syllabus we went over, PowerPoint information. So what I would do if I were you, okay, so you're going to be watching these PowerPoints. I would also print out or have pulled up your version of the PowerPoint that you'll be able to get from eLearn. Okay, I would take notes on that, either typing or writing. It's better if you can write with your hand and not type. Research shows that you retain more information if you write things out with your hand versus if you're typing them. So that's what I would do, is print out the slides and take notes as you go, because your PowerPoints are going to look a little different than mine, for starters. Secondly, I'm going to be telling you different things to add into your notes as we go. So again, you want to make sure you're writing those things down. Additionally, for each lecture, I'm going to post an outline for you. So what I would do is, like I said, print out the PowerPoint, write things in as you're watching the lecture or listening to the audio or however you do that. Okay. Then once you're done with that, you're going to go to the handout that's posted online. And I would fill in that handout and use that as a study guide. Okay, so again, go through that handout and what do you know, what do you not know, what makes sense, what doesn't make sense, and then that'll help you determine what you need to focus on for studying. Okay, so again, two different resources that I think would be super useful. You don't have to hand either of those in, but those are things that are going to be super helpful for you as you study for your exams. Okay. Homework policies we went over. Like I said, I guess my virtual office hours are going to be 8:30 to 11:30 each day. But again, like I said, if you have an immediate question, please text me. If you have a question that you don't mind if it waits, you know, a few hours for me to answer, then just email it to me. I'll get back to you. Okay. And then lastly, we're going to do an orientation to the human body. Let's get started, right? So when we think about anatomy, how did we define this? So anatomy is the study of the human structure. Okay, so basically we're looking at what are the names of things. Okay, so again, the also called morphology, or the science of form. So what is the form of the body? What does the body look like? So again, anatomy is one of the oldest forms of science, dating back to at least the 2,300 years. So again, this was something that was super interesting to people a long time ago, and very intriguing to them. Okay, the difference between anatomy and physiology. Physiology is the study of how things work. Right? So again, how do those systems work? How does the body, you know, utilize each of those components or each of those parts in order to complete a particular task? Okay? So again, when we look at this is structure, anatomy is the structure, physiology is the function. It's very difficult to separate those things. And a lot of times it makes sense for us to put those together, because understanding the function is highly related to how the structure is set up, or vice versa. It makes sense for us to understand what the structure is based on what we know it does, right? So again, it's very difficult for us to separate those things. However, in this class, we'll really focus on the structure piece, and in the second half of the class, in Anatomy and Phys 2, we'll spend more time talking about the physiology part. How does it work? How do things work together? How do these parts, you know, work together in order to create a complicated or complex system? So why do we care about anatomy? Again, this question will be better answered, I think, tomorrow when I get to meet you and find out what your career goals are. So I think I will just leave it at that for now. So maybe one thing to think about before I see you tomorrow would be, why do you care about anatomy? Why is it important for you in your profession, whatever your goal profession is, to understand the parts of the body and how things are put together and how things are organized? Why would that be important in your field? Okay. Again, for a lot of us, a lot of healthcare, so if you're interested in nursing or physical therapy, athletic training, all of those fields, we've got to understand how things are organized, where the muscles lie, how they're attached, in order for us to know if they are working correctly, right? So we've got to kind of know that baseline information in order for us to then apply disease or injury or something along those lines. In order for us to be able to repair that, we need to know what normal is, right? When we think about careers related to exercise science, okay, so again, strength and conditioning, for example, if I don't know where the muscles are or what they do, how can I best help someone to strengthen those, right? So again, I need to understand where those muscles are and how they move, how I can stretch them, how I can strengthen them. But the first thing I need to know is where are they and how are they attached to me? How do I use those to create or establish movements, for various activities? So again, those are just a few examples of why we might care about anatomy. So many different branches of anatomy. So we've got gross anatomy, and so basically that's just what do things look like with the naked eye, right? So again, it can involve dissection. So dissection of a cadaver or a animal product or an animal is also an example of gross anatomy. Okay. Think about regional anatomy. Again, I can look at the shoulder region, for example, and look at all the different things that are in there. Okay, so I've got muscles, I've got bones, I've got some neurons going through there. Okay, so the nervous system is involved. I've got blood vessels running through there. Okay, I've got some lymph nodes, right? So again, there's lots of different things located in that region. So I can choose to look at that one particular region in order to get a good feel for all the things that are located in that region. Again, if I'm a physical therapist, for example, regional anatomy is super important, right? I need to understand not only what muscles cross there, but maybe there's a neural issue, right? So what nerves cross there and what's going on with those nerves? What are those nerves doing? Okay, so again, it's important for us to understand regional anatomy if we're thinking about rehab or injuries, those types of things. We can also think about anatomy as it relates to systems. So systemic anatomy is when we think about the entire system. Okay, so the cardiovascular system, for example, is located everywhere, right? So I have my heart, which is here, but I also have blood vessels that are traveling literally everywhere in my entire body. So it would be hard for me to just regionalize the cardiovascular system into one particular location. However, it's important for me to look at the whole system and understand that systemic anatomy, right? So how do those vessels run? How do they connect to each other? How do they come to the heart and go away from the heart and things like that? So we can look at regional anatomy. We can also look at systemic anatomy as well. So in our lecture, we'll focus on systemic anatomy. So we'll look at body systems, such as the cardiovascular system, the pulmonary system, digestive system, etc. We'll look at each system. However, in our labs, we'll look at regional anatomy. Okay, so we'll look at the shoulder joint, we'll look at the hip joint, we'll look at the knee, etc. So we'll look at each of those different regions of the body as we try to understand what's going on with their muscles. Microscopic anatomy or histology is looking at things under a microscope. Again, we can look at tissues on the cellular level. Again, this is important because it gives us a better understanding of what's going on at kind of that lowest level or that baseline. Okay, so again, we need to understand what's going on from a microscopic standpoint so that we can gain understanding of what the function is of this particular tissue or structure. Developmental anatomy, so we're going to look at changes that occur in the body from fetus to the effects of aging. Okay, so developmental anatomy, looking at changes that occur in the body from fetus all the way through regular development, through adulthood, and then looking at the effects of aging. Okay. Embryology is looking at body structures and form before birth. Okay. So with developmental anatomy, we're looking at from when babies are born up until when they die, right? Embryology, we're looking at before babies are born, okay? So from when sperm and egg meet all the way up until they are born, okay? Pathological anatomy looks at structural changes due to disease. Again, super important if we want to understand, how a disease works so that therefore we can treat that disease. We need to understand how does it affect the form? How does it affect those structures in regards to, their general setup, I guess. So one thing that's important when we think about anatomy and how it might be different from a lot of other topics that you've maybe learned about in the past is this concept of an anatomical terminology. And most anatomical terms are based on ancient Greek or Latin words. Okay, so Latin has been deemed the official language of science, and anatomical terminology provides us with a standard that we can use worldwide. Okay, so again, let's say that I am a world-renowned physical therapist that works specifically with a tendinopathy of the piriformis muscle. Okay, so this is something that I just made up. That is an injury, but I'm not an expert in that area or anything. So let's say that I'm a specialist in that area. And let's say that there's somebody over in Australia who also specializes in that same particular topic. So in order for us to be able to communicate effectively and efficiently as we kind of work together to find best treatments for this particular injury, we've got to have kind of the standard, right? So anatomical terms are used, again, all over the world so that we can kind of create a more cohesive medical or healthcare environment, a science environment, so that everyone can kind of understand what's going on. So this stuff is just fun for me. I enjoy the history of anatomy. Again, I just want to go through this pretty quickly. We won't have too many test questions or anything on this material, but I just think it's interesting. So again, anatomy is considered one of the cornerstones of science. It's important in many fields, including medicine, healthcare, rehab, exercise science, coaching, etc. So a very important component when we think about, many different fields. So let me take you back to 1600 BC. Okay, so the Egyptians were the first ones to think about this whole thing, anatomy, right? So this guy, they began describing the heart, liver, spleen, kidneys, and blood vessels. So again, think of how long ago this was. Most things they had wrong, okay? They believed that there were two tubes in the right ear that carried the breath of life, okay? So that's how you stayed alive, was these tubes in your ear. And then you had two tubes in your left ear that carried the breath of death. Okay, so again, we want to stay away from those tubes or whatever. Again, they didn't have the function of many things correct. However, they did understand that the heart was a pump and that the vessels carried blood. But otherwise, most of their ideas, they were just kind of like making it up, and they were incorrect about most things. Okay. Fast forward a little ways here to 480 BC, and the Greeks began dissecting animals. They identified the optic nerve. So again, there's a nerve at the back of your eye that allows us to transmit images. So they figured out what that was. They also proposed that the brain was responsible for intelligence, which is correct. They also began comparative anatomy. So looking at the difference between a monkey, for example, and a pig, right? So what are some structures that differ? They both have hearts, they both have brains, but maybe how does size differ, and different factors like that. So they began comparing different animals. Okay. They determined the difference between arteries and veins. So arteries are going to carry blood away from the heart, veins are going to return blood to the heart. So they figured that out. Again, pretty advanced with the cardiovascular system at this point. They were the first to use human cadavers. So again, they were dissecting individuals in order to gain a better understanding of what was going on inside. They also used something called vivisection. So this is crazy. So vivisection is a live dissection. And so they would take criminals or people that were incarcerated in like their prisons, and they would just like cut them open so that they could see like the heart beating while this person was still alive. Isn't that so creepy? I guess that would be like a really good reason for me to not break any laws or anything else like that, because I don't want to get cut open alive. But that was like something that they did. So that's freaking crazy. That was going on. They also considered the blood the innate heat. So they thought that blood was equal to heat, which is actually kind of true. Like our blood does carry heat, and it is a very effective medium for us to carry heat. So that's kind of interesting. They also, you know, you've heard like songs and other things like that, like, oh, listen to your heart and things like that. Well, your heart is an organ that's going to pump blood everywhere, and it delivers oxygen and nutrients and picks up waste. That's what it does. But we have this kind of alternative meaning for heart, right? Like that love comes from your heart and things like that. That's came from the Greeks. So the Greeks believed that the heart was your breath or your soul. So again, maybe all these emotions and that sort of thing, they believed came from your heart, which again has stuck around amidst us understanding really that emotions such as love and, you know, listening to your heart, whatever that means, is actually coming from your brain, right? So again, super interesting that that kind of has stuck after so many years. Okay, 280, continuing with vivisection on animals such as pigs and apes. They also started studying wounds and trying to understand what they could do to speed up recovery of wounds and that sort of thing. So that was going on. Leonardo da Vinci, so again, fast forward again, quite a ways here, another 100 years or so, and he depicted anatomical drawings of the bones, the skin, the muscles, internal organs. He dissected around 30 human specimens. Again, they were all deceased. We're past the vivisection. And he was pretty darn good at producing these precisely drawn anatomical correct images. And the reason he was good at this is because he used math. So he would measure, okay, what's the distance from, you know, here to here on the average person? What's the distance? Okay. And so then he was able to create these very mathematical images based on these calculations that he had. Okay. So again, understanding the relationship, he was very smart at being able to figure out the relationship between, you know, different distances and how far it should be from each spot, depending on, you know, he measured hundreds and hundreds of different people and specimens and things like that in order to create these really accurate images. 17th and 18th centuries, again, invention of the printing press caused a large increase in curiosity as it relates to anatomy. So dissections were performed by certified anatomists. This happened yearly. This was like a big deal. To be a certified anatomist, that was like a highly like sought after career. Like that was a prestigious career to be in. Many cities had royal anatomists. And so again, these people were like very prestigious basically. And they did these dissections and charged an admissions fee in order for people to come in and be able to watch this. It was kind of like a theater, which is really weird. Because this was such an interesting topic and people were becoming so curious, they started noticing that there was people were like stealing bodies from graves, right? So so that they could dissect them and see for themselves and do their own like experiments. That was like a pastime for people. So in 1832, the Anatomy Act was put forward, and this supplied corpses of executed murderers. So again, we're back to using our prisoners. Again, they're already dead though this time around, so that's good. In order for them to be able to gain a greater understanding of anatomy. So to cope with shortages of cadavers and the rise of medical students during the time, body snatching and anatomy murder was practiced. So again, this was put in place to kind of help with some of those issues, which is creepy. Anatomical theaters, 16th century, again, there were centers for human vivisection. So again, places where people could come and these professors would teach lectures on anatomy as they dissected these people. Anyone was welcome to attend, and it was like in a stadium. So this was like entertainment for these people. This is kind of what this looks like, which is totally weird and creepy in my opinion, but this is history and I think it's really cool. So again, here's your royal anatomist down here. He's got a skeleton set up over here, and all these people are kind of gathered around so that they can, you know, learn as he's doing this dissection. 1858, Grey's Anatomy, not the TV show. This book here came out, and they have now coined the term gross anatomy. And this book has many, many images of anatomical structures that are visible to the naked eye. So again, looking at gross anatomy products, you know, Grey's Anatomy is still considered one of our like standard historical pieces of anatomy. 19th century anatomy, so we started doing more histology, developmental biology as well. So with the invention of the microscope, we're able to see what's going on at a kind of a lower level. So again, getting an understanding of what's going on within the cells gives us information to gain a greater understanding of what's going on at a gross level. So that started becoming more popular. Okay. Light and electron microscopes, again, so microscopes were introduced in the 1600s. You have a light microscope, which uses light to illuminate body tissue. And then there's also an electron microscope, which uses a beam of electrons, which are smaller wavelength in comparison to the light. And this gives us much more precise images and higher magnification. So the electron microscope, this is an example of red blood cells shown under the electron microscope. Again, the light microscope was good, but not as good as the electron. Again, here shows you a little bit of histology. So this is what blood might look like under a light microscope versus electron microscope here. Okay, so electron microscope, you're zoomed in a little bit more, and each of those little like red round things is a red blood cell. Here we're zoomed out a little bit more, and each of these little guys is a red blood cell here. Again, both are super valuable and give us a lot of good information about what's going on. You know, at a lower level. However, you know, you can certainly tell the progression when we're looking at an electron microscope versus the light. Check that out, isn't that cool? So again, this is looking at an electron microscope here. A nice image, you can see those red blood cells. X-ray imaging. Again, another way for us to continue to advance in anatomy that will allow us to identify breaks, things like that. So we're using electromagnetic waves. They're directed at the body and absorbed. The amount of absorption depends on the density of the matter encountered. So that's what allows us to create these images with the X-ray. And this was developed in 1895. Sonogram or ultrasound imaging. Again, now we're sending pulses of high frequency sound waves that can reflect or echo off of the body. And actually, I should show you some better images. This is just a very basic sonogram, but it's even more advanced now. Like you can see the freaking kid's like face. You can see what they're gonna look like. Again, like I mentioned to you already earlier, I'm pregnant with twins. And we've been able to see both of the girls' faces, and people keep saying that one of them looks like my husband and the other one looks like me. So it'd be interesting to see if that's true once they're born. But the clarity of the images is just absolutely amazing to think about when we think about how sonograms work and ultrasound. Ultrasound is also a treatment used sometimes for injuries via, you know, athletic trainers and physical therapists, but we can learn about that later. Again, modern anatomy, again, we've developed some other techniques and other toys to kind of get a better understanding of what's going on as it relates particularly to pathology. So again, disease, injury, those types of things. We've got MRIs, CAT scans that we can use to get a better understanding of what's going on. Here you can see ACL versus a torn ACL. This, I believe, is an MRI. So MRI produces high contrast images of soft tissue. So again, we're able to take a look at some of these soft tissues that surround the knee, that surround these bones, in order for us to understand what's going on with them. Here's a CT scan. It's a computed image. Sorry about the dog. Just barking at the neighbor. So again, here's a CT image. So we can look at kind of like slices within the brain, and we could look for tumors or growths that aren't supposed to be there, and different factors like that. So now back to things that you really do need to know. Again, we've kind of looked at where we came from as it relates to the history of anatomy. And now we want to take a look at the levels of structural organization within the body, okay? So again, we're going to start at the most basic level here with an atom. And an atom involves a chemical level. Atoms form molecules such as CO2 or H2O, okay? So that's what a molecule is. A macromolecule might include carbohydrate, lipid, protein, nucleic acids such as RNA or DNA. And these are going to serve as building blocks for structures at the cellular level, okay? So that's what a macromolecule is. Again, organelles are specialized structures that are found within cells. Cells are going to be kind of like the most basic unit of function, I guess we could say. And a group of cells together is going to create a tissue. Okay, so a tissue is a group of cells that work together to perform a common function. There are 4 different types of tissue. And again, we've got a whole lecture on tissue that's coming up in a couple days for you. So you'll learn about all about those 4 different types. That includes epithelium, connective, muscular tissue, and nervous tissue. Organ is a discrete structure that's made up of 1 or more types of tissue. Most organs contain all 4 types of tissue. The brain and the heart are 2 examples of organs. And then next we have organ systems, and organ systems are several organs that are going to work closely together to accomplish a common task. So the cardiovascular system, for example, contains the heart and the blood vessels and the blood in order for us to, move nutrients, oxygen, and waste products. Our organ systems include, and again, we've got a unit for almost all of these, and if we don't cover them in this class, we cover them in the second half of this class later this summer. Organ systems involve or include the cardiovascular system, pulmonary system, integumentary, skeletal, muscular, digestive, lymphatic, nervous, urinary, reproductive, and immune system. Okay, so all the organ systems together work in community unison in order to create the organism. Okay. So again, when we think about gross anatomy, a couple things that we want to cover, and again, this will become super important when we go to our lab tomorrow. Gross anatomy will include anatomical position, regions of the body, body planes, and body sections. Okay. So anatomical position involves erect posture with our face forward, arms at our side. You can see her here. Palms are supinated. So again, her palms are facing forward. Okay. Thumbs and fingers are in extension. So again, her hands are like just basically like flat like that. Okay. And this is what anatomical position looks like. Again, her feet are about shoulder width apart. Knees are in extension as well. Erect posture, erect spine. Why do we have anatomical position? This is used as a common visual point of reference. So again, we'll talk more about what that means tomorrow when we do our lab, but essentially this is kind of like your starting point. So then we can describe where things are located based on this, or we can describe movements based on their deviation from our anatomical position. We can use directional terminology in order for us to understand, like we said, what's going on with the body, and this will serve as our starting point. Also, one other thing to note when I'm talking about this person, for example, okay, one thing to remember, and again, this is kind of common sense, but maybe not for everyone, right? We can think about the subject's left hand is their left hand, okay? So this is her left hand, okay? And this is her right hand. So make sure we think about left and right as in her left or right, not yours, right? Does that make sense? So her left is on her left side, her right is on her right side. So it's kind of opposite of what we see as looking forward at her in the mirror. Again, we think about regional terms. We have names of specific body areas. We have two different regions that I want to kind of discuss today. We have axial region and appendicular region. Okay, so the axial region includes head, neck, and trunk. And the appendicular region will include our appendages or extremities. Okay, so the axial region includes your vertebral column, your ribs, your skull. Appendicular includes your appendages, okay, so it includes your arms and your legs. Pretty simple. Okay, next thing I want to kind of introduce, and again, we'll spend the majority of our time tomorrow in lab talking more about this and kind of applying these things. These are our planes of motion. So we have 3 different planes of motion. Again, this allows us to understand movement, and this will give us an idea of how different joints can move. It allows us to kind of classify these joints and muscles based on the different types of movements that are allowed. Okay, so transverse plane kind of cuts us into an upper and lower half. The frontal plane kind of cuts us into a front half and a back half. And the sagittal plane will cut us into a right half and a left half. Okay, so again, sagittal plane divides our body into a right and left section. Generally, flexion and extension occur in this plane, and again, we'll go over this tomorrow, but I do want to kind of stand up and give you some examples now, so I hope you have your video on. So again, imagine that you had this kind of plane that kind of cut you into a right and left. So in order for me to have movement occurring in this plane, I want to like mimic that plane, right? So I don't want to cross over that plane. So flexion and extension will occur in this plane. Let's see if I can move this down so you can see my legs a little bit here. So, you know, hip flexion, hip extension, I'm not crossing that plane if something was to cut me into 2 halves. So flexion, extension of many joints are going to occur in that kind of that sagittal plane. Again, if that's confusing to you, don't worry, we'll talk more about it and kind of clear that up tomorrow. Frontal, or the coronal plane as it's sometimes called, will cut us into a front half and a back half. So movements that occur in this plane include adduction and abduction. So I want you to imagine that there was something that cut me into a front half and a back half, right? So abduction and adduction are going to mirror that plane. So bringing my arms out to the side, this is abduction. Adduction is bringing them back towards center. Again, I can do those same movements with my legs as well. So abduction, adduction of either arms or legs is going to allow movement in that frontal or that coronal plane. Okay. Transverse plane, again, this will cut our body into an upper and lower half. Movements in this plane include pronation, supination, and rotation. So let's take a look at some of these. When we think about rotation, not crossing the plane, okay? So rotation, I can do rotation like this. I can also do internal, external rotation of my shoulders. I can also do internal, external rotation of my hips. So pointing my toes in, pointing my toes out, okay? Or I could go like this, internal, external rotation, okay? Pronation and supination is going to involve movement at my wrists. So this is supination, cup of soup. I can hold a cup of soup in my hands. Pronation, dump the soup out. Okay, so supination, pronation, supination, pronation. Again, it's a rotary movement that will occur in that sagittal plane. In reality though, you know, like those are all nice and that's really neat and everything, but when we do any type of complicated movement, we're going to move in more than one plane, right? So we have this oblique plane, which is going to combine many of those movements. So again, you can see here an example of swinging a golf club, but again, you know, a lot of you who maybe are athletes can think of many other motions that you complete in your sport that are complicated, that are going to require you to move in multiple planes, okay? And that is what the oblique plane is that combination of more than one plane. Okay, let's see, a couple more slides here. When we think about orientation and directional terminology, again, we'll cover this tomorrow in lab, but I wanted to kind of give you an introduction to these so you can maybe get into your notes and get some definitions written down, and then we'll kind of bring those to life tomorrow when we have an opportunity to meet. Okay. So if something is superior, it's above, okay? So it's higher than. Something that's inferior is going to be below, okay? So those are kind of like opposites. Inferior, oops, I'm sorry, we just did inferior. Anterior is towards the front, and posterior is towards the back. Okay. If something is medial, it's closer to the midline. So the midline of your body, so just imagine that you had a line that went straight, you know, straight down the very center of your body. So if something is medial, it's closer to the midline. If something is lateral, it's further away from the midline. If something is cranial, it's closer to your head or your cranium. If something is caudal, it's closer to your tail or to like your tailbone, or, you know, like the most posterior inferior portion of your hips. So again, you know, we don't have tails as humans, but we still use this term. So cranial up here, caudal is down here. So it's towards, basically towards my tailbone. Okay, something that I can't really demo for you now, but we can come up with some examples, and that'll be important when we think about muscle layering, is superficial and deep. So superficial means it's towards the outside. Deep means that it's internal. Okay, so for example, my skin is superficial. The babies are deep. Okay, so they're inside or they're deep in comparison to my skin that surrounds them. Okay. Ipsilateral and contralateral, these are commonly used when we talk about injuries, pain, different things like that. So ipsilateral is the same side. Okay, so again, if I said that I had ipsilateral pain related to my shoulder injury, I was feeling pain in my elbow as well. Okay, so again, same side. So if it happened on my right side, my right shoulder had an injury, maybe I'm also feeling that pain in my right elbow. Okay, contralateral is opposite. Okay, so again, I could use that when I think about sports specific movements. So for example, I coach track and field, and so in high jump, for example, I want to create a push and pull mechanism using contralateral movements. Okay, so again, we kind of give you a demo here. So when we think about push and pull, I want to push down into the ground and pull and drive up in order for me to create the most momentum that I can if I wanted to get over that bar. So contralateral is the opposite side. Okay, so I'm going to do something different on either side. So it's contralateral. Okay, and then proximal and distal has to do with its point of attachment. So if something is proximal, it's closer to my point of attachment. So again, if I think about my arms, for example, something that's proximal to the point of attachment, it's got to be close to my shoulder. Something that's distal is going to be further away. So something that's distal might be my wrist, for example. It's further away from my point of attachment than what the shoulder was. Okay. So again, those are kind of comparison terms that we could use to describe where things are located. Additionally, we've got some body cavities and membranes that we should take a look at. Let's see. I think I will show you what each of these are on the next slide. Yeah, I think that's probably going to be the easiest. I think I've got images on the next slide to kind of show you what each of these are. Okay, so regions of the body. So again, starting with this blue oval in the top, this is the cephalic region or cranial region, sometimes called that. Red circle surrounding the eye is known as the orbital region. Yellow circle surrounding the mouth is known as the oral region. A is pointing at kind of the neck, and that's going to be the cervical region. B is pointing at the top of your shoulder, and again, we'll talk about this when we get to our shoulder unit. That would be the acromial region. C is kind of like your armpits, and that's going to be axillary. D is brachial, so arm means brachial. Let's see, what else do you need to know? H is thoracic. Okay, so that's your thoracic cavity. I is abdominal. I'm just kind of flipping to the ones that I really want you to know. N is femoral. So again, your femur lies within this area. And O is patellar. So like your knee area, for some examples. Okay, so again, when we look at the back side here, A, you can see here, that's kind of on his shoulder blade, which is known as scapula. B, in this particular area, known as our lumbar region here. Those are two examples there. Here we go, here's some nice ones for you. A, cranial, so again, this is the cavity that will hold your brain. And then B is our vertebral cavity. Okay, so it holds the vertebral column. So A and B together are sometimes known as the dorsal cavity, and dorsal means towards the back. Okay, so dorsal means back. So this cranial and vertebral cavity together create the dorsal cavity. C is thoracic, as we kind of already mentioned, and D is abdominal. Underneath D here, you can see the pelvic cavity. If I combined both D and C, so the things in red here, those are known as ventral body cavities. Okay, so ventral means towards the belly or towards the front. Dorsal means towards the back. Okay. Let's see, what else do we need to know here? So you've got, again, this is just another image to kind of show you. We've got thoracic here, cranial, vertebral, abdominal here. One thing to point out over here, if we were to kind of divide out the thoracic even a little bit more, we've got pleural cavities, which are kind of this greenish color, and that will hold the lungs. And then we also have the pericardial cavity, which will hold the heart. There. Yeah. So we have these serous cavities, and serous means fluid-like, or it's got a layer of fluid with it. And we have these cavities that are fluid-like or wet, think of it that way, that are surrounding heart, lungs, and visceral organs. So the cavities don't contain air, but they contain a thin layer of serous fluid. Why do we want to have this fluid lining? Again, think about what the heart and the lungs are doing all the time. They're moving all the time, right? So your heart is contracting all the time. So if there was no fluid surrounding it, we would have some friction, and that could cause abrasion. So this fluid lining is super important because it allows us to create this smooth surface so that each time the heart contracts, it just slides along that lubricated surface, versus if it was dry, it would create friction, and that could be super painful or cause damage to that particular organ. So that's one reason that having this fluid lining is super important, not only in the heart, the lungs, but also your digestive organs as well. As food moves through the digestive tract, it's important that, it's got the serous lining so that things stay smooth. Okay. Well, let's kind of look at how this works. So the pleural cavity, I have two layers. Okay, so I have an internal layer, which is known as the visceral pleura. So visceral is on the inside. Parietal pleura is on the outside. So parietal is superficial, visceral is deep. Okay, between those two things lies serous fluid. So there's fluid in between these two like little linings. Okay, the way I remember this is parietal is parent. So the parent's on the outside, and then visceral is on the inside. So parietal is always on the outside because he's the parent, he's like protecting. Okay, so you've got parietal pleura, serous fluid, visceral pleura. Okay, Same thing is true with the heart. So we have parietal pericardium is on the outside of the heart. Then you've got that serous fluid, and then you have visceral pericardium, which is the deepest. Okay, so from deep to superficial, we have visceral pericardium, serous fluid, parietal pericardium. Again, like we said, we have the kind of the same setup going on within our visceral organs as well. The major difference here is that that parietal layer kind of surrounds everything. Okay, so again, you can see the parietal peritoneum is on the very outside here, and it's kind of surrounding everybody. Everybody fits into one bag. And then we've got the inner layer, the visceral peritoneum, is deep, and then we've got that serous fluid which lies in between. So parietal serosa is the most superficial, then we've got serous fluid, and then visceral serosa is a little bit deeper, and that will directly surround the organs. This is just interesting, I think. So we think about anatomical variability, and you think about the difference in people. I'm sure, you know, the difference in people within this class even will be really interesting for me to always see. I love this. So people differ so greatly in their external anatomy. So look at how different each of these people look in this particular, you know, chart, right? So variability exists internally as well, but more than 90% of our internal anatomical structures match these textbook descriptions. So I think what is super interesting is from the outside, yes, we look very different, right? But internally, we're all pretty darn close to the same, which I think is just absolutely intriguing when we think about, you know, the difference of people and kind of what we perceive. But when it comes down to it and we look at each of these systems, these things hold true for everyone, regardless of what you look like from the external. Alrighty. I'm going to stop share there. Thanks for tuning in. Again, that's lecture number 1 for you. And I will plan to hopefully see each of you tomorrow. And I'm looking forward to getting to know you. Again, if you do have questions on this, please just let me know. All right. Have a great day.